So my name's Gary Ward. I'm in the microbiology and molecular genetics department, and I'm going to talk to you about publishing today, one very specific aspect of publishing. But just by way of introduction, let me say that I spend a fair amount of my time thinking about how we might improve the way that scientific publishing works. There are issues with access to research results. There are issues with peer review as it's currently practiced. I think we would all agree that it takes way too long to publish data. Publications should be much more interactive than they are. We're still acting like we lived 200 years ago by focusing our publishing around the PDF. And as the literature is expanded, especially into these huge undifferentiated journals, there's issues with how we find the things we need. But I need to pick a very small piece of that today, and Charlie asked me to focus on this question right here: how we evaluate the significance and impact of a piece of research. And I think if I were to ask, if we were to do a survey right now, because I've done this before, that at the top of everybody's list, when you just are presented with a CV and you're trying to figure out which work is most important, the surrogate that's in practice today for importance or impact is the journal title or the impact factor of that journal. And I have one job here today. The one job I'm going to try to do is to convince you that that's not a good way to evaluate impact. Okay? But I'm not going to do this just by telling you that it's not a good way, because I think we all are sort of uncomfortable with the impact factor, but we kind of go, well, we have to live with it. It's the only thing out there. So what I'm going to try to do today is to be really data-driven, not raise my voice, and just present to you three reasons why the impact factor, impact factor is the most quantifiable way to look at journals in this way, but you can also think of it as the title of the journal or the prestige of the journal. They all relate to the same thing. We think when we see Nature, it means something about the articles in that journal. And I'm going to make three arguments. First of all, the impact factor is a deeply flawed metric, and I'm going to walk you through that and show you why it's. I'm going to tell you what the impact factor is, and then we're going to discuss why it's such a flawed metric. Secondly, where a work is published is based on a very subjective decision-making process that's anonymous, and it's often incorrect, and involves a very small number of people. And then thirdly, and I think this may be the most convincing of the three arguments, is that any measure that is based on journal averages or journal aggregates is not at all predictive of individual articles in that journal. Okay, so those are the three arguments that I'm going to make today. But before we do that, I want to do a little quiz. So we all think we have an idea what the impact factor means. Those of you who are in the ethics class, you're not allowed to answer this, okay? So I've scrambled the names of journals here, and I want you to imagine that you have an article that you're going to submit, and you're obsessed with the impact factor. So you're trying to figure out which journal to send it to. And I have scrambled these journals in terms of their actual impact factors. What do you think are the top three journals in here in terms of impact factor? Cell, yeah. Cell Science, Nature.
I think the annual reviews.
Why do you think that?
Because people cite review articles.
Yeah. Yep, that's voice of experience speaking there. Not that you cite review articles, rather than. Okay, so I, in fact, didn't scramble these. We're going from lowest to highest here. So Cell, Nature, and Science, the three that you thought had the highest impact factor, everybody but Chris, actually are not. They're beaten out by Annual Review of Immunology, by this cancer journal, and surprisingly, this crystallography journal, ACTA-A, which probably, how many of you have heard of ACTA-A? How many of you would have thought that was the number 2 impact factor journal? So the year that I chose here was the year 2010, and there's a specific reason for doing that, which I'll show you in a minute. Okay, so just to demystify the impact factor a little more, let me tell you exactly what the impact factor is. It's a very simple calculation. It's a measure of how frequently the average article in a journal has been cited in a particular 2-year period. So if you want to calculate Nature's, let's say, 2014 impact factor, what you do is you look in the year 2014 to all citations in any journal published to articles that were in Nature in the preceding 2 years. Okay, so that's the numerator of the impact factor. The denominator of the impact factor, to normalize it to the total number of articles published, is the total number of articles published in 2012 and 2013. So the impact factor is simply the number of sites divided by the number of articles published. Okay? It's a very non-mysterious but complicated calculation, it turns out. These are published by a for-profit organization. It used, not 2,200 or 2012. They're published by a for-profit organization, used to be Thomson Scientific. It was recently bought by another company called Clarivate. And they're only available by subscription, so you can't actually go online and look for them legally, but we can get them through the Web of Science in our library. Okay, so what's wrong with this, right? Simple, it seems to make sense. What's wrong with this as a metric? So I'm going to tell you first, we're going to start with the point that I told you I was going to tell you about, that it's a deeply flawed metric. So the first point is that it doesn't distinguish reviews from research articles. And this is what Chris pointed out. So if you take, these are, I think, the 2014 impact factors. If you look at the top 10 journals in terms of their impact factor in 2014, 6 out of the 10 of them are review journals. And that's because reviews get cited. We're all lazy and we cite reviews rather than going back and citing the original articles. It also means that journals try to game the system by publishing more reviews. I've been on an editorial board where the editor-in-chief told me that I need to go out and solicit 10 mini reviews per year so that we can bump up the impact factor of the journal. Not that the field needs more reviews, but it would help the impact factor of the journal. So that's the first thing. If you're trying to measure the importance of a research article, you're being compared to review articles. The second thing is that there's a really disproportionate effect of blockbuster papers. So this is why I chose 2010 in my little quiz, because these are the data from 2008, 2009 from ACTA-A, that journal that was number 2 in the 2010 impact factor. This is out of a total of 7,387 journals. ACTA-A was the second highest impact factor. The previous year, it scored 2,118. So what happened to make it jump from 2,118 to 2? Its impact factor went from 2 to 50. The answer is that there were 72 articles published in 2009. 71 of these were cited 3 times or less, but one of them had 5,624 citations. And that one article was enough to bump this journal up above Nature, Science, and Cell. And this is an article about software for solving crystal structures from single crystals, where Sheldrick, the guy who developed the software, has directed the crystallography community to refer to that as the key citation. So that one article bumped them from 2,118 to 12. Now I'll tell you again, I was actually at an editorial board meeting just a few weeks ago where the editor-in-chief said that they're worried about the impact factor of their journal. So what they're doing is they're actually going to offer a package that involves money, publicity, travel to a meeting to people who have potentially blockbuster papers to solicit them for their journal, because they publish a small number of articles, and if they were just able to recruit 4 or 5 articles that have higher than usual citation rates for their journal, it would dramatically increase their impact factor. I'm not going to tell you what journal that was because I'm hoping that they will back off that idea. But okay, so those are 2 of the reasons why it's flawed. A third reason why it's flawed is that it doesn't account for differences in the citation behavior of different communities or the size of the citing community. And since Chris Houston here is, I often use Chris as an example. If Chris was still working on entamoeba and discovered a cure for entamoeba histolytica, you know, a scourge of humanity, he wouldn't get probably 1/50th the number of citations for that paper that somebody working on P53 or in the field of immunology, just because the communities are so much bigger. So it's not, it's a one-size-fits-all thing that really penalizes people in smaller communities. Okay, but I think the most, the most problematic aspect of the impact factor calculation is that the number of articles that go into the numerator and the number of articles that go into the denominator are different. So for example, if you're a medical journal and you publish a bunch of letters or editorials, those are often cited by people, and they count in the citations that your journal gets, but they don't count as a citable item in the denominator. This happens all the time. Mini reviews, some journals they count, some journals they don't, but they're always counted in the numerator, not in the denominator. So how's that decision made? It's made by the publishers of the impact factor negotiating with the publishers of the journal. And I'll tell you my own personal experience from Public Library of Science. We have a journal called PLOS Medicine that 3 years into its publication, when it became eligible for an impact factor, Thomson Scientific came to the offices and said, you know, your impact factor as we currently calculate it is going to be 3. We think that's way too low. So let's see what articles we could move out of the numerator, out of the denominator to make your impact factor higher. And in fact, those negotiations would have resulted in an impact factor that varied between 2 and 11. There's a really wonderful article, 2 articles that have been written. This one is by Mike Rossner in Journal of Cell Biology, and this one is by an author named Palagas, that talk about this fudginess in the impact factor calculation. In fact, what Mike Rossner did is he bought the data from Thomson Scientific and tried to calculate the impact factor for his own journals, and it didn't work. So he called back Thomson Scientific and said, listen, I didn't get anywhere near, and they said, oh, we sent you the wrong database. So they sent him a second database. He still couldn't calculate it. And so his point here is that we're all scientists. We rely on reproducibility. We rely on transparent methods. And yet we allow our career advancement to be determined by something that's completely subjective and negotiable. And I'm going to give you, again, another specific example of this. So this is for the journal Current Biology. And what you're seeing here is the total number of items published in Current Biology 2000, 2001, and then the impact factor in the year 2002, 7.07. Then the same journal, the number of published items in 2001, 2002, the impact factor over here. So that's the denominator over the numerator. Now, Current Biology's impact factor jumped by 5 points between these 2 years. But if you look at one number here, there's something that's particularly unusual, that in 1 year, the number of citable items was called 528. That very same year, for the next impact factor calculation, it was called 300. They had about the same number, they published about the same number of articles, but the impact factor jumped 5 points because Elsevier bought this journal in this year. Thomson came in and negotiated with them. So between this year and this year, the very same issue of the journal, after Elsevier did the negotiation, Thomson Scientific considered that they published 300 articles that year, 300 citable articles, not 528. So that's a great specific piece of data showing how fungible the impact factor is, and also the power that a publisher like Elsevier has to manipulate those things. Okay, so hopefully you agree that there are problems with the metric. The second point I wanted to make is that relying on impact factor as a way to judge quality of science, and by transference, the quality of scientists, right? I mean, that's really what we're talking about here. It seeds that decision about what's important to 2 or 3 reviewers. And I just want to remind you of how our current publishing system works. The typical thing that we do is we write up our paper and we shoot high, right? We submit it to the highest impact journal we think it has even the remotest chance of getting into. If the decision is yes, well done, good for your CV. If the decision is no, you get it back, you know, a month and a half later, you reformat it, you resubmit it to the next highest impact journal in the hierarchy. Another 2 or 3 reviewers are involved. If they say yes, okay, well, we're all right with that. We didn't have to go too far down the hierarchy. If no, you just keep doing this until it ultimately finds its right level in the hierarchy, right? I think we would all agree that's pretty much how we publish these days. So is that really how we want our career to be determined, right? By 2 or 3 reviewers who may have their own agendas, they're anonymous, they may have had a bad day driving their kids to daycare that morning, whatever. And I want to give you an example, a somewhat embarrassing example from my own past that has to do with a paper that we wrote up about 10 years ago, submitted to the Journal of Biological Chemistry, and it got editorially rejected. So the letter said this paper has a nebulous focus, doesn't relate directly to a physiological relevant pathology or potential use of the compound. Both the editors concluded the work is too preliminary for publication in our journal. JBC has an impact factor of about 4.5. So since there really wasn't any useful criticism there, we just reformatted it and we sent it to a Royal Society journal, and has about the same impactor of JBC. It was immediately accepted. It's been recommended for publication. The referees rated this paper as being very significant, and we'd like to promote your work as a hot article. In fact, it ended up as and this has never happened to me before. I strongly recommend acceptance. In fact, the paper is sufficiently significant that the Royal Society might consider publication in a higher impact journal. We decided to, you know, the foot was in the door. We decided to take it. But these are two journals with exactly the same impact factor. These guys rejected it out of hand, and these guys suggested that they weren't good enough for it, right? So that just gives you an idea of how capricious the system is. And when you're basing, you know, your estimate of the quality of a piece of work on where it's published, you're agreeing to this kind of variance. Okay, the third point I wanted to make, and this one has some data that I think some of you may not have seen before, is that any metric that involves journal-based aggregates to measure impact is not good because those journal-based aggregate measures don't correlate with the performance of individual articles in the journal. So what you're looking at here is a citation distribution spectrum for the journal PLOS Biology. So you can see there are very few articles that have 0 citations. The mean is somewhere, or the median is somewhere around 18. And there's a very long tail, goes out. There are some articles in there that receive over 150 citations. And this kind of skewed distribution is what the citation distribution looks like for all journals. All journals. Here's what Science's distribution looks like. So this is not a normal distribution. So the first thing you might say is that since they aren't normal distributions, it's completely wrong statistically to be looking at the means, which is correct. But that's something that Thompson has been told for years, and they're not changing that. So first of all, mean is not a good way to characterize the distribution. But more importantly, what this means is that there are a small number of articles that get a large number of citations, but the vast majority of articles, no matter what journal you're talking about, whether it's PLOS 1, PLOS Biology, or Science, the distribution looks very similar. The difference is in how many rare events are out here that have large numbers of citations. So here's again some data. 89% of Nature citations are generated by only 25% of its articles. So that means that the other 75% are basically getting a free ride on the reputation of Nature because of those 25% that are highly cited, right? That doesn't say that they're good articles. It says that they're in a journal where there are some highly cited articles. And the converse is also true. So this is kind of an interesting observation. And when I say the converse is true, what I mean is that, you can have a journal that you think doesn't publish anything worth reading, but in fact you can't say that either. So if you go to Google Scholar and you click on the metrics tab, what you'll see is a list of articles by basically a list of journals by their H factor. And what the H factor is, means is a journal with 366, an H index of 366, means that Nature over the last 5 years has had 366 articles with 366 or more citations. So you see Nature, you see Science, as you might expect, you see The Lancet, you see Cell, and you're just scrolling down this list thinking, oh, this makes sense. Wait a minute, there's PLOS 1 at number 25 in the list. PLOS 1 ahead of Nature Medicine, Blood, Nature Biotechnology, Nature Methods, BMJ, Neuron, Nature Reviews Genetics, Nature Neuroscience, right? That's kind of surprising that there's more highly cited articles in PLOS 1 than there are in these other journals. Now, the reason why, of course, is because PLOS 1 publishes a huge number of articles. But the point is that there are more highly cited articles in PLOS 1 than here. So you really can't tell based on where it's published where those good articles are. That's really the point of this. Okay, and this, I recently discovered this, and I think it is really the most damning bit of evidence arguing against the impact factor. as a way to measure importance. So what you're looking at here are the citation distributions. This is from a blog post, by the way. What you're looking at here are the citation distributions for different journals that you might intuitively think you have an idea for who is going to produce the more highly cited articles. This is JCB versus Journal of Cell Science, EMBO Journal versus JCB, Nature Cell Biology, and then Nature versus Journal of Cell Biology. Now, if you had two distributions that looked like that, you'd have to go to some pretty significant somersaults to prove that those distributions were different. And this is my favorite, actually. So this is from Nature itself in 2013 versus 2014, where they made a big deal about the fact that their impact factor jumped from 38.597 to 42.351. Now, first of all, reporting impact factors to 3 significant decimals. But they made a big deal that the quality of research, the quality of papers in the journal was increasing. This is what the citation distributions look like for those 2 years. There's zero difference between those two. So what that tells us is, first of all, if impact factor has any value at all in terms of predicting impact, you can't be looking at differences of this size. Maybe the difference between 2 and 20 tells you something about the average article, but doesn't tell you about any individual articles in that journal. Okay, so as Mencken said, for every complex problem, there's a simple solution and it's wrong, right? And that's really the story of the impact factor. It's there, people use it, it's simple, but it's wrong for this purpose. It wasn't invented for, it wasn't developed for judging the quality of articles. It was developed for judging the average value of a journal to librarians. For that purpose, it's probably okay, right? As long as you take into account size of field. But somehow it's been, I don't want to say, I was going to say the word perverted. Yeah, I'll say the word perverted. It's been perverted over the years into a use for which it was not intended, and it doesn't serve well. So because I'm trying to stay focused on the impact factor, I'm not going to tell you today about what alternative metrics might be. I have some ideas on that. Chris Houston is going to be presenting, is it the next one, Chris? So Chris is going to be doing one of these sessions in April where he talks about a calculation called the relative citation ratio. That's certainly an improvement on the impact factor in terms of being able to gauge how important an individual contribution is. If I were to say what I think the principle should be behind how we measure the impact or importance of a paper, this is key. Assessment should be done at the level of the article, not the journal in which it's published. That's key. Second thing is that citations are really only one of the article level metrics. We've been talking only about citations. That's one measure of impact, but it's not the only measure of impact. There's a great example from PLOS Medicine where in the second year of PLOS Medicine's existence, it published a paper on calculating collateral deaths in a theater of war. And as you might imagine, it didn't get a whole lot of citations, but it actually changed NATO policy for how they conducted war in the Middle East. And you know, how you capture that, or one of my colleagues at Public Library of Science, she works on climate change. Her publications speak to farmers. They don't actually speak to other scientists. She gets huge numbers of downloads, but very few citations. She's having an impact, but it isn't captured by citations or where she publishes. Third point, and this is particularly important for the younger people here today, different metrics will be useful at different times after publication. Citations take a while to build, right? So if you're a postdoc out looking for a job, you need some other way to convince people that what you're doing is important because you can't wait for citations. And then, as the two examples I gave here might suggest, you want to give the users the tools to pick the metrics that are most relevant to them. So the NATO example or the example of my colleague who works on climate change, she should be able to make the argument that all of the downloads and the IP addresses they're coming from are really suggesting impact, even if citations aren't showing it. Okay, and I'm going to give you, you know what, we're going to skip over this because I want to make sure we have time for discussion. So this is sort of the take-home message. The importance of research output should be assessed based on the work itself rather than the impact factor or title of the journal in which they're published. Okay, and the last few slides, I just want to talk about why this matters. why it should matter to any of us. And Harold Varmus coined the term CNS disease for our obsession with publishing in Cell, Nature, and Science. So what are some of the consequences of CNS disease? The first is that it has a dramatic effect on how fast science moves. Because of these iterative cycles of publishing, we shoot high. Oftentimes we go through 3, sometimes 4 journals before it finally finds a home. This is a survey that was published in Nature a couple of years ago, and what it shows is just how slow the process can be. 50% of the authors surveyed waited somewhere between 1 and 3 years to have a piece of work published. It's actually kind of remarkable. 22% waited somewhere between 2 and 5 years. So there's a real opportunity cost to this, right, in terms of the scientific enterprise. When things take, you can imagine if all of the work that we do got published, let's say, in a week, just to put an extreme, how much faster science would move, right, than waiting 2 to 3 years. And I particularly like this formulation of the problem from my friend Mike Eisen. Here's how long it takes median submission for publication in biomedical journals, which is about as long as the length of a major baseball season. It's 4 times as long as it takes to cross North America on foot. It's just a little less than it took Curiosity to go from Earth to Mars. And not much less than human gestation from conception to birth, where there's a lot going on that isn't happening in publication. Okay, so there's a real opportunity cost to the fact that this system slows down science. Second thing is that it wastes a lot of time, right? I mean, we spend a lot of time reviewing papers, editing papers, only to have them be rejected, sent to another journal. It wastes author time because you have to reformat them. So it wastes a large amount of time. The amount of effort that's spent on peer review in the United States is estimated to be about $2.8 billion. And a large percentage of that is not the peer review that results in publication, it's the peer review that results in rejection. But I think the most pernicious part of the impact factor problem, and it has to do with the way that it has corrupted the incentive system for science. Because what we're doing now is we're basically marketing our work is what we're doing. We're marketing our work to try to get it into the highest impact journals possible. And because of that, well, actually, I'll just read. The incentives associated with increased pressure to publish in high-ranking journals encourages scientists to be less cautious in their conclusions, or worse, in an attempt to market their research to the top journals. This is reflected in the decline of negative results, corroborated by finding that much of the increase in retractions may be due to misconduct, and that much of this misconduct occurs in studies published in high-ranking journals. Okay, this is a really terrific article, actually, that summarizes the consequences of journal chasing, basically. There's very good evidence at this point that structures that are published in high impact factor journals are not as reliable as structures published in lower impact factor journals. There's a direct correlation between the number of retractions and the impact factor of the journal. Actually, there's one of the things that he discusses in this article is there's this interesting phenomenon that virtually all results show a decline effect, which means that when they're first published, the effect is larger than in subsequent replications of that same observation. All results in science follow that effect. So we're encouraged to oversell our results, basically. But the effect is much higher for high impact journals. So there's a much bigger difference between the size of an effect when an effect is first reported and the size of that effect 2 years later in high impact journals. And so I think it's clear that in order to get papers into these high impact journals, you know, they have to be polished. There can't be any open-ended results that don't get explained. People cut corners. They do what they need to get the results into the journal rather than actually presenting the science as it is. And if you question that conclusion, I would encourage you to read this article here, which describes real-life examples of that happening. So to me, that's the most important consequence of our reliance on a flawed metric, is that it really corrupts science by putting the wrong incentives in place. Probably many of you have heard of cash awards in different countries for science. So let's just take China, for example. In China, 90% of universities pay their authors bonuses for articles in high impact journals. And it's not insignificant. The average payment for an article in Nature, Science, or Cell in China is $43,000. Yeah. There was one, yeah, let's all move to China. There was one highly publicized case just last year where a group was paid $2.3 million for a publication in Cell. And this is not just China, by the way. This is worldwide. There was recently a little article in Science where they reviewed cash incentives in countries around the world, and this is widespread. So, I mean, it's not surprising when you've got cash rewards, when you've got career imperatives to publish in high-impact journals, that people are going to do what they need to do to get their articles published in high-impact journals. And the solution is to decrease our obsession with those high-impact journals. Okay, so I'm just going to finish by saying if you believe what I told you here, and I realize that I went partly from fact to a little more opinion here, although it isn't entirely opinion. There's a lot of data supporting it. But if you believe the idea that the impact factor is a bad way to measure the quality of science, what can you do? So the first thing is there are some big things going on out there that you could become involved in. Your societies, many of your societies, unless we're talking the American Chemical Society, which is sort of the professional equivalent of Elsevier as a publisher, but most other societies have been actively working to decrease the reliance on it because for their membership, who are scientists, this is a corrosive influence. So you can get involved in your society's efforts. But on a much more practical level, you know, I could tell you publish your next Nature paper in PLOS One or Journal of Biological Chemistry, and I'm not going to tell you that because that's not a good idea, right? Career-wise, at the state we're at right now, if you have a Nature paper, you should try to publish your paper in Nature. However, that doesn't mean that while we're, you know, all trying to work within the system, we can't be trying to undermine the system. And I want to give you two examples of how you can try to do that if you bought what I told you today. The first is to just push back on people who use impact factor or journal title as a surrogate for quality. And I've given you data here today that can help you do that. Don't just tell them it's a bad way to do it. Tell them why it's a bad way to do it. Journal-based aggregate measures are not an appropriate way to measure individual papers in a journal. The metric is flawed. You can do that for the faculty in the room in hiring, promotion, grant review. And here's one that everybody in the room can do, your own seminar presentations. I'll tell you that when I go to a seminar and I hear somebody say, they're discussing somebody else's data, and they say, you know, as Tolley presented in his Nature paper, or as, or as Houston presented in his Science paper. They don't typically say that. If you listen, they don't say as Houston presented in his PLOS One paper, right? They don't say that. Why not? So there's like, it's implicitly reinforcing this idea that because it was in Science or Nature, it's a better paper, which I hope I've convinced you it isn't necessarily. So here's what I do. I take the names of journals off my slides altogether. And I put the PubMed ID number because if you're putting the journal title down here, presumably if you're not promoting the journal, presumably what you're doing it for is that if somebody wants to go and find that article, they can write it down. It's way easier, in fact, to write down an 8-digit number than it is to write down the journal, the data. So this is one thing that you can do. It's not going to cause you any harm, but it will undermine this idea. And I challenge you all over the next few weeks, when you go to seminars, just listen to how often this happens. The other thing about pushing back, I can tell you that I'm on the CAL's Faculty Standards Committee, and I think my committee members wish I weren't, wish I was, because I spend a lot of time pushing back on this. Whenever people try to use impact factor as a measure of quality for the dossiers that come through, you know, I try to educate them again about why it's not and that we need to be looking at other things. So there are many venues in which you can push back on this, and if everybody started pushing back on it, its value would disappear. And then the final thing I want to suggest to you, and this again we can all do, is experiment with and use different metrics on your own CV. You probably use RCR on your CV, right? You should.
I do.
Yeah. So there are various metrics you can use. I have a number of papers that have been cited over 250 times. It doesn't really matter where they were published if they were cited 250 times. I include that on my CV. That actually means more than the title of the journal that they were published in. So experiment with, a number of journals now have alternative metrics that you can pull down and see how your article is doing compared to other like articles, and you can use that in your CV. I wouldn't say replace your CV at this point with a completely altmetric CV because the world's not ready for that. But you can certainly augment, and as people who are looking at the CV start to see the value of when Chris includes an RCR value, a relative citation ratio value on his CV, they'll start to see the value of that, and they'll start to look for that rather than the journal title. So those are two things that I would encourage you all to think about doing. It will have no career consequences, no bad career consequences for you, and it will help to undermine the system that I just presented to you. Okay, I intended for that to take 30 minutes. It took a little longer, but I wanted to leave some time for disagreements. Challenge.
So what's the important proposal of how to judge an article when you're just going in PubMed, search an article? Title sounds good, abstract sounds good. Would you then look up how often it was cited to determine if it's really a good article, or is it that you really have to go through and read through and then determine if you can't rely on it?
So, you know, that's a complicated question, and it depends on the reason you're looking it up, right? If you're looking it up because you work on toxoplasma and you find that article in PubMed, if the abstract's interesting, you're going to read it no matter where it's published, right? If what you're trying to do is find, you know, the hottest articles, if you're sort of browsing, looking outside your field, then there are a variety of metrics that you can use, and Public Library of Science is experimenting with this right now, where instead of relying on, you know, the editors and the reviewers of the journal to tell me what I'm interested in, you rely basically on the wisdom of the crowd and my own personal preferences. So I can set up a search. I can set up a search now where I look for things that you know, are directly related to what I do. I can add on to that a term of what's been the most tweeted about in this area recently, which one has gotten a larger number of citations in the first 6 months than it should have. There are a number of ways that you can construct a search to capture those things that aren't directly related to you, that have the same goal of trying to find the most interesting, important, talked about work without relying on journal title, I think is what I would say. You know, let me give you, I will give you, since you asked the question, let me just show you an example, because I think this is a really instructive example. So back in the year 2003, I'm an editor on the PLOS Biology editorial board. In the year 2003, I served as editor on 2 articles in the field of malaria. This first one came from Joe DeRisi's lab, and it was a beautiful, beautiful paper on the transcriptome of the malaria parasite as it went through its life cycle. In the same year, I edited an article from Masao Yuda's lab on the malaria parasite and how it gets into liver cells. Okay, so these were 2 articles, both on malaria, both edited by the same person, and both published in the same journal in the same year. So if you go to the PLOS website, and again, I'm doing this for PLOS because I'm more familiar with PLOS, but many journals do this, and you click on the metrics tab for each of these articles, what you'll see is a real-time set of alternative article level metrics for each of those articles. The last time I did this was about a half a year ago. So here's the DeRisi article, and here's the Yuda article. And what you're seeing here are the cumulative number of views since it was published. So when I did this search back in June, it had been published 166 months ago, and you can see it was actually being viewed almost linearly over the whole period. Sorry, that's not right. It was continuing to be viewed even 166 months later. This is the actual pattern that you would expect for the average article in biology and the life sciences. So even in the field of malaria, which is quite small, this thing was getting a lot of attention. Its figures that had been deposited in Figshare had been accessed 200 times. It had been cited almost 1,000 times in the Scopus database. It had been recommended by 3 reviewers in Faculty of 1,000. It had been discussed on social media. There were 3 Wikipedia entries, right? Here's a whole suite of metrics that you could pick from. The Yuda article, on almost every single one of these metrics, scored 1/4 as high. So instead of 45,000 downloads, 11,000 downloads. Instead of 1,000 sites, 200 sites. Instead of 3 Faculty of 1,000 mentions, 1 Faculty of 1,000 mentions. there's just no question when you look at the data displayed this way, which has been the more impactful paper in the field of malaria, right? There's no question. And if this one had been published in EMBO Journal and this one had been published in Nature Communications, you know, you'd be left sort of scratching your head, which is the more important one, you would know. Whereas these metrics tell you immediately, if you had to choose, so coming back to your question, if you only had half an hour to choose to read a malaria paper, you'd read this one, because this one has been more impactful. So this is just one sort of formulation. It doesn't include the relative citation ratio or all of the other things that are being developed, but I think it's illustrative of how there are smarter ways to do this than basing it on journal title. This one here, compared to all biology and life sciences, is about the average. I'm not sure, did that answer your question? Yeah. I'd like to be able to, we should all be making I should make the Journal of Gary Ward that has that has everything in it that I want to read, because I have the tools to go out and find it based on these different metrics, is what I would say.
Yeah, it would be nice if that would be shown in PubMed, like next to the article. So
not all journals, you know, that would be nice. That would be really nice. So that when you're searching, that would be really nice. Not all publishers present them, and they don't all present them in the same way, which is a problem now, because I would really love on my CV to not only be able to say this paper was cited 350 times, I'd love to be able to say, which is in the top 1 percentile of all papers published in the field of parasitology. And I can do that now for PLOS, for Public Library of Science articles. They actually give you that capability to compare it not just to biology and life sciences, but because I'm involved in PLOS, there's a pull down here that says parasitology. So I can compare it to all parasitology, but that's only in the PLOS corpus of literature. So there's a really pressing need for publishers to get together and come up with a set of standards. And if they did, then maybe it could start to be displayed on PubMed. But right now, everybody does it a little bit differently. So I don't think PubMed would want to get into that business quite yet. Yeah.
I mean, in the business of having a journal, isn't working together would undercut having a prestigious journal?
Well, so that's a really good point. My position on this has always been, and I've been working through PLOS to try to get more and more publishers to adopt it, to adopt a standard set, because if 70% of the publishers are following a set of standard, alternative metrics, and Nature Publishing Group isn't, soon they're going to be forced to do it because other publishers are offering something they aren't, because they're now comparing themselves against a much bigger corpus of literature than just the Nature Publishing Group. So I think there would be a tipping point. You're right in one respect that there isn't the incentive for publishers to play well together at this point, but if enough of the literature could be moved in this direction, in the same way that open access started off as a fringe movement, but now that it has become a successful business, everybody's trying to get into the business. So I hope that there will come a tipping point. But right now it doesn't exist, you're right.
I think related to the citation, like what counts for the citation?
Yeah.
Just more generally, I think. So we have this thing in our field where citations are all about other people doing novel research, setting out work, as opposed to secondary articles, periodical, whatever, picking up our stories.
Mm-hmm.
And so in our field, it's not happening quite as often. And when it does happen, we don't get citations for that. We only get citations for other scientists.
Right.
Are there metrics that are looking into the more generalizable citation? What a citation is, how much value you give it? Because other fields, I was looking at a paper in educational psychology and an impact factor of 1.031. I know because they told me they were very proud of it. That affects policy and affects change.
Yeah.
Just not in.
Yeah. So this comes back to that sort of principal point I was trying to make, that there are things other than citations that matter, and it's important to provide people with the tools to access those and be able to use them in their CV. So, for example, if my paper, I always, when I have a paper that's recommended by Faculty of Health, I include that in my CV, right? That says something right there. I'm doing a sort of a circuitous route to answer your question. One of the early indicators, for those of you who are younger scientists, one of the early indicators of downstream success of a paper is how well it gets picked up in reputable blogs and by science bloggers. And so this is something that PLOS has tried to follow, and at various times you'll see blog entries in this article level metrics thing, because that's one that is much more time insensitive and is proving to be really well correlated with downstream success. Other things like views and downloads, you know, there's some value to them, as you can see from this example, but they aren't predictive. But blogs is looking to be a little more predictive. So that relates to, you know, that relates to whether a journalist picks it up. What I would say is that wherever you work, the public affairs office, the communications office, is pretty good at tracking when something to come out of UVM has been mentioned by an article. You should absolutely collect those. And if there's more than one, if there's a couple of them, you should include that in your CV. It was featured in, it was, and you know, that's not a sort of systematic metric, but in specific cases, if you're in an impact factor journal of 1, but it's been picked up by the press or it's changed policy, for sure you should be mentioning that. You should be highlighting that in your CV. It's getting that information, right? Which is, but the communications offices are generally pretty good at knowing when anything that's been done here has been talked about. So if you have reason to suspect it might have been picked up, you could check with them. No.
Wondering if you know, or if anyone knows, whether altmetrics are more or less sensitive to evening or attacking compared to a closed source.
So there's been a fair amount of work done on that. Okay, so let me answer that question a couple of ways. First is, let's not pretend that the current system of peer review isn't subject to gaming, right? It's like if we're, and what journal it gets into has a lot to do with who you are, where you're from, who reviewed it. So it's not like the current system is free of that, right? Having said that, how do we prevent gaming in an altmetric system? First of all, you know, TripAdvisor, Amazon, they've figured this out. And there's a lot of lessons to be learned. And PLOS and eLife in particular have done some pretty interesting experimenting on this. It turns out that if you look at the suite of altmetrics, they tend to track together. There are complex relationships between them that you can, over time, since there's such a huge database, you can figure out how they relate to each other. And so what journals that present altmetrics do now is they monitor that for all their articles. And if they see a spike in downloads that isn't accompanied by the other things, it becomes suspicious. They track it down. They then start applying some filters like what IP addresses are they coming from. So there are a number of ways that are public. That's one of them. And there are a number of ways that are not public that they're working against gaming the system. Yeah, and I'm actually pretty confident that most of the data that are presented by the publishers that worry about this are pretty solid and robust, as solid and robust as the conventional peer review system is, I would say, maybe even more so. Yeah.
You mentioned there must be data on it because you did bring it up that certain journals are more prone to retractions than others and it correlates with impact factor. Is there a way to calculate a retraction factor for a journal that would be public knowledge before publishing in it? Or to say, you know, you look at a journal and say, okay, well, 25% of what they publish is junk science versus a lesser impact journal that's never retracted an article. You might be more inclined to say, like, okay.
It isn't, first of all, it isn't 25% for any journal. You know, the numbers are small.
Yeah.
So there's the relationship right there. And there is the retraction index is a factor that is normalized to the number of articles that are published. This was published in, I forget which ASM journal it was, but if you want to look it up, it's quite nice analysis. And it talks about, you know, we can't actually say, when you look at data like this, that the problem is the pressure to publish in those high journals. Let's be fair about this. That's certainly a contributor. It may be that articles that are published in these journals get more scrutiny because they're more widely read. There's probably multiple contributing factors here, but the rest of the data that I referred to argues that there is a component of this that relates to people's imperative to publish in these high impact factor journals, cutting corners, and so on. They published a subsequent paper showing that the majority of retractions weren't innocent mistakes. They're actually due to fraudulent behavior. So what's driving the fraudulent behavior? I think you can connect the dots. So yeah, those data are out there. And Retraction Watch, whoever said Retraction Watch, yeah, it's a great site. You can go on there and you can get data on all
You
the
can
journals.
get an email every day about all the latest news on retraction.
Yeah.
That's great.
You know, some of
They rank scientists by the number. I mean, you know, it's the guy who runs it. I was at a talk that he gave. It was fascinating. I signed up immediately. But now I can get 1 or 2 emails every day, and I just don't delete them all. But I don't know if you've read that site. But
I actually,
actionwatch.com.
Yeah. It's a little aggressive and unaccountable, I think, is what I would say. You know,
I haven't studied it.
it's a little Wild West, but they have turned up things on Retraction Watch. You know, days after things have been published in Science or Nature, things will show up on Retraction Watch that, you know, they noticed a figure that was duplicated, or they noticed that the statistics couldn't possibly be generating this level of significance. So I think it serves a purpose, and I think every scientist should live in fear that they're something that they've done.
Well, I think they're not just identifying it, they're just cataloging it. So, you know, they kind of catalog all the retractions and look for patterns. So if you see the same author in multiple retractions, you know, they know that.
Yeah, they work
Find out.
in collaboration with a sort of a post-publication peer review evaluation group that will, you know, they're hungry to find errors, and then they share them with Retraction Watch. So I think it serves a good purpose, and we should all try to be as squeaky clean as we can so that